C2 problem. Yeah. Okay, here we go. Someone has to look at a C2 problem this week in class. This is just a C2 problem. You got some more practice for our retest on Friday. C2 problems have to do with an object moving in vertical motion, so it's moving up and down. So a few things we need to remember there. We're normally dealing with gravity equaling negative 9.8 meters per second squared. The only time your acceleration in the vertical direction won't be that is if you have some sort of rocket booster going off or something else happening, in which case I'd tell you what the acceleration is. We have to remember that the up direction, we like to consider that positive. So if you have an initial velocity, you know, maybe it's going up, it's a positive, or if it's going down, like you threw it down, your initial velocity could be negative, or you could have a negative final velocity or a negative, well, hey, or if it's going up, I don't know how you'd have a positive velocity going up, but you could have a positive velocity going up. You know, maybe you caught it, just a quick little snapshot. But positive values, negative values. It's also important for us to remember is this object goes up and it turns over in its arc and it comes back down. When it reaches the same height position, its displacement is 0, and the initial velocity and the size of it, so like the absolute value, is equal to the size or the magnitude, the absolute value of the final velocity. It's all the same. So if this was like positive 7 going up, coming down at this final position, the same position it started with delta x equals 0, you know, it'd just be minus 7. So 7 is 7. Okay, so that's just some important stuff there. We also know that if it takes the entire time to go over here, it only takes half of that time to go to the very tippy-toppy point. Okay, so that's some important stuff we need to keep in mind for a problem like this. So let's just imagine for a second we have a problem where someone, I don't know, takes a baseball, it's playoff season, and they take the baseball and they throw it straight up. And they throw it up with an initial velocity of 4 meters per second. Okay? I want to know, how long does it take to fall back down, back to their hand? And that might seem like a really crazy question to think about, but it's really not, because we know a few things here. We know the acceleration of gravity is equal to negative 9.8 meters per second squared. And we also know coming back down when it gets to this point, we know that the final velocity is going to equal negative 4 meters per second. If I have initial, a final, an acceleration, I'm looking for time, I can actually use equation number 3 here. Vf equals Vi plus At. Negative 4 equals 4 plus negative 9.8 times time. If I want to work that out, I'll subtract the 4 first, so I'm going to get negative 8 equals negative 9.8t, and then I will divide the negative 9.8 out on each side. Note how my negatives remove themselves, and time is something a little less than 1. Okay, it's probably actually closer to 0.8, something around there. Okay, 0.8 something. Seconds, because it's time. So that's how we can kind of look at a problem like that for a C problem. Something closer to what you saw on the first test could be something like for another C2 problem. This is another C2 problem. You could see something where maybe, you know, you're sitting on a cliff. You're like, oh, I'm sitting on a cliff. This is a nice cliff. Isn't this great? I'm having a great time. And then I don't need this sandwich anymore. And you throw a sandwich off a cliff. I don't know why you'd waste a sandwich in that regard, but there goes my sandwich. Okay. When you're throwing the sandwich, maybe you're disgusted from it and you throw it straight down. Okay. Maybe when you throw it down at a initial velocity of, and since it's down, negative 10 meters per second. We already know gravity is negative 9.8 meters per second squared. And then let's say it takes a total of, I don't know, 2 seconds to hit the bottom. Well, the question becomes, how high is your cliff? okay? In this case, we can actually use equation number 5 for that. We can say that delta x equals the initial velocity, negative 10, and we have to remember this negative, okay? We threw it down, so it had to be negative, because we're calling down the negative direction. Multiplied by our time here, 2 plus 1/2 AT squared. And there's a great song that goes to that by this really cool physics teacher, Wink. Don't forget the square. And then you put all that together. So you're going to get negative 20. 2 squared is 4. Half of 4 is 2. 2 times negative 9.8 is 19.6. So your answer here becomes negative 39.6 meters. Okay, that's a kind of typical problem that you could see for that. You could have a variant of this where maybe you've decided to sit on the cliff and you're like, oh, this is such a nice cliff. But instead of throwing your sandwich down, you're throwing it up at initial velocity of plus 10 meters per second. And let's say that the acceleration stays the same, and let's pretend it's like a slightly different cliff such that the time stays the same. Well, if the time stays the same, but you threw it up before it hit the ground, you're actually going to be on a smaller cliff. Just because this burrito, as it's traveling, or the sandwich, whatever we had in our hand, I can't remember, in the 2 seconds, it's going to go up and down. And it's going to take 2 seconds to here. It didn't need to go forever. It was just 1, 2. This was 1, 2. But because it was already moving down, we covered more distance. Okay? It's the same equation. It's just equation number 5 again. Except this time, when we use equation number 5, delta x is just positive 10 times 2, that's the time, plus 1/2, negative 9.8, gravity, if we're calling down the negative direction or inward, it's still negative. You didn't change gravity. If you could, let me know. We can save the world, times t squared. Okay? You'll get a different number here. In this case, you'll actually get 20 positive minus 19.6, which means that your cliffside was actually only 0.4 meters high, which means you were maybe on like the 3rd step at your house. Okay, so that's just one way we can look at some of these problems. Remember C2 vertical problems, you need to remember this stuff here. Acceleration is negative 9.8. If you're moving upwards, you've got positive quantities. If you're moving down, you've got negative quantities. If you're coming back to your initial height, your initial velocity and your final velocity are the same. If you're coming back to your initial height, your delta x equals 0. Okay? If it takes you the total time to go through the full up-down, then it takes half the time to go halfway. And those are the things you need to remember about Unit 3 C2 problems, kinematics in a vertical direction. I'm Mr. Botzer, and we're Finn.